It's my pleasure to welcome you to today's BioNanoNet Gold Member Webinar. And I think without further delay, we can directly start into the short introduction from my side. We have 4 presentations, which we have scheduled nicely after each other with really very comprehensive and interesting topics. And all of them should bring into your attention what the scientists of our gold members are offering to contribute to create some societal impact with their work. And this comes from new technologies for specific therapies, over the acceptance, the interaction with the people out there, that they find out how they will deal with the new technologies. On the other hand, a really very prominent topic at the moment, the life cycle thinking, all about sustainability. And finally, we will have also a presentation about a specific kind of technology, the 3D printing, which might be quite familiar to some of you, but also has some nice add-ons that can be useful for you in your future research work. With this, I like to kindly ask now Marisa Koini to keep her camera on. We can switch off the other cameras in the meanwhile, so that we have the speaker only there. Thank you very much. Marisa Koini is a scientist at the Medical University of Graz in the Department of Neurology in the Division of Neurogeriatrics. And looking into her profile, some keywords like brain imaging or clinical neuropsychology, but also Alzheimer's disease, for example, pop up, which I think totally very much interesting topics nowadays. And today, Dr. Koini will talk about the new technologies in dementia therapy. With this, Marisa Koini, I hand over to you.
Thank you very much. So I hope you can see my presentation. Thank you for the very nice introduction. As you already said, my name is Marisa Koini and I work at the Department of Neurology, Division of Neurogeriatrics. And as the name says already, our focus is on research, but also on clinical work with dementia patients. This is mainly driven with Alzheimer patients, but of course, we also have all sorts of other types of dementia in our ambulance. But we also, since we are a neurological department, see patients who have stroke or epilepsy or other forms of neurological diseases. Today, I would like to give you an introduction to new technologies in dementia therapy, which mainly focuses on what is already on the market and what is our focus in Graz. I would like to start with some key facts about dementia. Dementia is a neurological disorder which is mainly driven by cognitive and functional decline, which is progressively over time. And this is much more than you would expect than in normal aging. So the functional and the cognitive decline is even more in patients who have dementia than in normal elderly. Its worldwide prevalence is approximately 55 million, and every year 10 new million cases pop up. There exist modifiable risk factors and non-modifiable risk factors to become dementia. Non-modifiable would be, of course, the age, but modifiable risk factors are, for example, a higher blood pressure, or diabetes, obesity, smoking, drinking alcohol, physical inactivity, or also being socially isolated and depression. It also is a major cause of disability and dependency among older people. There exists several common forms. So the most common form is the Alzheimer's disease type, which make up about 60 to 70%. And this is followed by vascular dementia, Lewy body dementia, and also other forms of dementia. There are early signs and symptoms. Of course, this list of symptoms is not complete. It starts most of the time with forgetting things or recent events, or misplacing things, getting lost when walking or driving, and so on and so forth. This list gets longer and longer with disease progression. However, despite so many people affected, dementia has no therapy. It is incurable. There exists medication that could delay the disease progression a little bit, but however, there is no cure. And therefore, it is even more important to find ways for the affected people and also for their caretakers to maintain independence and to raise their quality of life. And this is where the new technologies in dementia step in. The aim of these technologies primarily is to manage lifestyle, monitor cognitive performance, ensure security and safety for the affected people, deliver rehabilitation services. And there are already a lot of different wearables, which are more or less biosensors, it's just another word, on the market that are already in use. This includes wearables such as tracking the heart rate or the motion, or even the oxygen saturation. It also can track the bed light or the sleep pattern. It tracks the blood pressure and so on and so forth. So these are techniques that can be installed at home or at the patient itself, that monitors the patient and is possible. It has the possibility to send information to either the caretaker or even the physician. So this is one column of techniques that is implemented. The other column is where our research steps in. Because what we are doing is we want to try to maintain the cognitive function. And we just finished a long study with beginning Alzheimer patients, so with a very mild course, where we implemented a tablet-based training, which the patients did for 6 months. And we compared the data of these patients who trained with the patients who just had unsupervised paper-pencil training. This was a randomized control trial, and all patients in the intervention group and in the control group had before and after the same examinations. This included a neurological and a neuropsychological examination, brain imaging with functional and structural magnetic resonance imaging, and blood sampling. The intervention group then received the 6-month tablet-based training, while the control group just received the unsupervised paper-pencil training. Here you have some examples of the tablet-based training. You see it is a subtraction task or a drag and drop puzzle, and just a simple memory game. One of our primary outcome measures was the mini-mental state examination. This is a short screening which is internationally widely used to grade dementia patients into mild, moderate, or already the severe course of the disease. You can achieve 30 points. The more points you have in this screening, the better it is. And it asks for rather simple questions for healthy people, but rather difficult questions for demented people, which is, for example, the current date or the current location where they are. It also asks for a memory, it also includes a memory task or calculation, or what you can see here, a drawing a figure task. So this was our main outcome, or one of our main outcomes. And what we found in our multimodal study was that the intervention group over time, so what you can see here is the baseline and the 6-month column, so after 6 months training, and the intervention group maintained their cognitive function while the control group decreased. So their global cognitive function in the control group got worse and in the intervention group did not. We were very enthusiastic about this result because it was only a 6-month training. However, I put that image of that old lady with the glasses on top just to remind myself and all the others that this result needs a repetition. The tablet-based training is now also available is downloadable in the app stores. So if you're interested, you also could have a look into it. It's available in many different languages already, and it now also includes a very neat dashboard, as you can see on the slide, where you can see how often you have trained, which results you had, if you get worse or better, and so on and so forth. So if you're interested, you could download this and try it out. Another column of our research focuses on virtual reality. This is of particular interest, especially for me, since you can train here activities of daily living in a relatively safe environment. And what we did here, or what we have here, is a activity of daily living supermarket, buying groceries, and in the end, going to the cash desk and pay for all the groceries you have in your consumer basket. I want to show you a short promo video to give you an insight how this looks like. It was a cooperation between the Medical University of Graz and the FH Technikum Vienna. At the beginning, you have to learn a list. So it is a memory task at the beginning. You have to learn a list of items you then have to buy in the grocery store. So you can see that right now. It's just 2 things. It's beer and fries. And now you walk through the market, and while looking at the items, you can put them into your consumer basket. If you have any items in the basket that do not belong there, just look longer at them and they go back to the box where they belong. It was critical how the patients will walk through the supermarket because they have to sit, otherwise it would be too dangerous. So they have to look at those black dots to move forward and backward. At the end, they go to the cash desk and have to do the activity of daily living, of paying and summing up the amount of money they have already given to the person, then push the red button. And in the end, they also get a short feedback on how they performed, as you can see here. And there are also 4 different levels of difficulty. Those are the 2 columns. We are currently working, or our research is focusing on at the Department of Neurology. And if you have further questions, I'd be happy to answer them now. If you're interested in any form of collaboration, please just contact me. I would be happy to answer you. Thank you.
Thank you very much, Marisa, for this great talk. It's really inspiring, and it also connects already different technologies for, let's say, medical purposes, which you may never expect that they have anything to do with medical technologies. I was just impressed now from your video about this virtual reality tool. Can you please elaborate a little bit on the key parts that you would be interested to offer within the setting of a research project? So either in the clinical part or more on the, let's say, technology part.
So you mean if I would write a proposal and I would want a new research project, which parts would be in it, you mean?
Exactly. What is your part?
Actually, I'm writing one, and it is a virtual reality, and I would like to do together with the company and together with the Technicum Vienna, who is programming the paradigms for me. And the aim is to find several different activities of daily living, such as grocery shopping or grooming, brushing teeth, or preparing the medication, just so things of activities of daily living that dementia patients are forgetting. So they can learn in a safe environment how to do these things to delay their cognitive decline and their functional decline over time. Does that answer your question a little bit?
Definitely. You mentioned that you're already preparing such a proposal. Maybe you have already all the expertise needed for a proposal, but if you have anything which you might want to get other partners involved, maybe for this proposal or for your future work, which expertise would you most seek for that?
Expertise is always welcome, of course. Expertise in, of course, technical stuff would be very welcome, such as other variables in general, but virtual reality variables, how this exactly work, how this could work with dementia patients, because there is also the thing of motion sickness and how we could get rid of that so that the patients do not get sick while wearing it. But then there is also many open questions about safety and security and data protection. Yeah, I think there are many different aspects where help is absolutely welcome.
Wonderful. Thank you very much for this great presentation and also for the answers to the questions that popped up. With this, we kindly ask to come to the next speaker now. Thank you once again, Marisa, for your presentation.
Thank you.
Our next speaker will be from the University of Graz. It's Professor Andreas Strebinger. He is Professor of Marketing and Business Analytics at the University of Graz, and his research is also in the field of consumer needs branding, including digital transformation, which is nicely linked also to the previous talk, I would say. And of course, those things are key items today as well. Buying the big in a book, barriers to consumer acceptance of non-transparent technologies is the title of his talk. And I'm super curious about your talk. Andreas, the floor is yours.
Thank you very much, Andreas, for the intro. Thank you very much, Marisa, for the exciting presentation so far. So I'm really looking forward to the next ones to come. So I'm Andreas Strebinger, and I am since October of last year, I'm Professor of Marketing and Business Analytics at the University of Graz. I'm at the Department of Marketing, and obviously kind of the odd one out here today. So I have no medical or technical background, but this is pure social sciences. So I do analytics as well. Today I brought you a presentation on the more marketing-y side of my work, which I hope is interesting for you in its own, and maybe there's some overlap with some of the problems that you are trying to solve or address in current or future research. So the topic of my talk is on barriers, particularly cultural barriers to consumer acceptance of non-transparent technologies. So these are technologies that we also call black box technologies, because the consumer has...
Andreas, do you want to share some slides?
Yeah, I thought this is done already. No. Thank you very much. So to prove my point, I have no technical expertise. So I'm a social scientist and lost in all forms of technology. But I hope I can contribute some things about how poor users and consumers, non-knowledgeable ones like me, adopt these new technologies. We were working on black box technologies where the consumer has the feeling, to buying the pig in a poke, or to buy the cat in a bag, as we say in German. This research was completed together with Professor Horst Treibelmeier from Model University in Vienna and was partially done while working at York University in Toronto. So without much further ado, we can go to the definition of black box technologies. These are technologies where users perceive a non-transparent relation between input and output. Empirically established examples are AI or DL and blockchain, but also genetics and nanotechnology, and there are certainly many more examples of that. So those are difficult to understand in principle for the users, and this is important for our research, they create fear of losing control. Now, this losing control is inherently kind of detrimental to user acceptance of new products, services, applications with new technologies. So everything else being equal, unsurprisingly, consumers prefer technologies that they perceive to be highly controllable over such that are not. And of course, black box technologies are by definition perceived to be less controllable. Our question was, after this has been firmly established in research, so how do cultural factors moderate this effect? And our feeling was that Western cultures are particularly skeptical when it comes to black box technologies. I'm teaching and researching a lot in Asia, and I'm always struck by the ease with which users in Asia adopt these new technologies, very pragmatic, even playful at times. So you'll find robots in restaurants and hotels in Chinese, even in 3-star hotels, people marrying AI characters, and mobile payment have been a thing for at least 10 years, even on like street markets in developing countries. Some of these technologies are really scary from our perspective. You know, there's Bitcoin ATMs in Vietnam, crypto game rooms in the metaverse, and the Korean marketing industry is already dominated by virtual characters. So these are advertising models that look and behave and talk like real people, but they're not. On the other hand, in the Western world, we have had some sort of, let's call it, field experiment in how parts and pockets of the society can reject new technologies, even if life-saving. So the question is, does culture play a role here? And I want to say, I'm not advocating anything is good or better or worse. You know, like I'm taking a purely empirical, descriptive perspective. So I'm not saying we should or should not be skeptical towards black box technologies. Also, we have to be, you know, very cautious with stereotypes about cultures. Of course, people in the West have certain characteristics, but there are huge differences within cultures. So with that said, we believe that there's two things that make black box technologies less likely to be adopted and accepted in Western cultures, which are individualism and rationalism as two of the pillars of Western culture. Think of yourself in such a level 5, fully autonomous car. No steering wheel, no brakes. So I guess you may not feel comfortable here. The individualistic person in you may say, well, you know what, I want to be in charge. I want to be in control. I'm responsible for what I'm doing, and I'm responsible for the outcome. I want to have the option to, you know, actually influence the outcome. The rational person in you would say, you know what, I'm not sure what this machine is actually doing. Why is it driving the way, where it is driving, how it is driving? I want to understand that. So these two elements make the adoption of black box technologies in Western cultures less likely. This is also grounded in a lot of previous research showing that people in individualistic cultures need more control, And as black box technologies create this fear of losing control, it's not rocket science kind of to put 2 and 2 together and expect that this relation between the controllability or the lack thereof of black box technologies is stronger with user acceptance, is stronger among individualistic consumers because they want more control. They have a preference for new product services that are controllable. As for rationalism, we always try to explain consumers, users, things with scientific narratives, but we have to be aware that a good chunk of the population doesn't necessarily understand or buy in these rational narratives. So another approach would be just use analogies to non-rational narratives. So for example, to magic, and just say, you know what, it's not always necessary to fully understand what it does as long as it works, and works in an ethical, good way. And we have something called belief in magic, which is kind of the opposite of rational thinking. So there's a good part of the population who believes in causal relationships for which there is no scientific explanation. That could be healing hands or building buildings in a way that they, enhance, your fortune, your good fortune, lucky numbers, talisman, rituals, and so on. That is high in Asian cultures, but we also have quite a large part of the population in Western cultures that believe in such non-scientific rationales. That is important because people who believe in magic and that they can control the world with magic, they have this illusion of control, expect to be lucky and take more risks in a good way and a bad way. When it comes to black box technologies, we would simply expect that the more people are believing in some sort of supernatural happenings in the world, the more they're actually likely to try black box technologies if primed with the right magical narrative to it. So in the interest of time, I can only give a short glimpse into what we did in terms of the research. We had 5 quantitative experimental studies in US, Canada, and India. Also additional smaller studies in other countries, including Austria. We used multicultural sampling. That means like we had samples with various cultures in one country, in particular Canada, but we also compared different countries like US and India. We had in total more than 2,500 respondents and more than 15,000 observations, because respondents always evaluate multiple scenarios of services with AI and blockchain. These were our representatives of black box technologies. So they would, for example, evaluate a new service that helps them to invest money, either fully autonomously, and AI does it and they cannot overrule it, or they the AI makes suggestions, recommendations, but they still have an option to overrule it. Or rent a car, self-driving, with or without steering wheel, customize vitamins, everyday things like buying flowers, or having a ChatGPT like AI professor, paying with facial recognition, again, always with or without the option to take control over what the AI does. And for blockchain, we had hotel bookings, peer-to-peer hotel bookings, and also money transfers internationally. So as for the results, yeah, I'm gonna not go through the details. Maybe we can look at that later in the discussion. But the point is, we found very, very consistent, very strong support for our model, meaning that consumers who are high in individualism are more skeptical to adopt black box technologies, whereas consumers who believe in magic, particularly when primed with some magic narrative, they are more ready to try out black box technologies. So that, of course, creates stronger barriers to the adoption of such black box technologies in Western countries, where the users are less likely to buy the pig in a poke or cat in a bag. Well, again, I'm not saying this is good or bad. Maybe that's a very good thing that users in Western countries are more skeptical towards black box technologies. We should be aware though that Western cultures are not like a monolithic block of all highly individualistic consumers. There are some who are super individualistic. Let's call them like kind of freedom lovers, right? So they would be particularly sensitive or skeptical towards black box technologies, and they are on the other hand users that have a tendency to hold supernatural beliefs of various sorts. And they actually are, if you use the right analogy, for example, about magic, they are more likely or more willing to try out these black box technologies. Well, the gold standard, of course, in designing new technologies, given these findings, is still to open the black box. That means, create technology with a maximum of transparency, explainability, accountability. That helps everybody, particularly those who want to have this transparency, are highly rational and individualistically in their worldview. But if you can't at least give those users some sort of control, that means can be the metaphorical red button. That means something to stop it, or give a code, a password to approve it, or override the system to give back some sort of control. Also have human support. We also found that this increases the feeling of being in control. So have customers, patients, citizens have a human to talk to give assistance, explanations, help with failures of the user or of the technology. And when you communicate about your new technology, don't only try not to only use the scientific narrative. There is a large proportion in the population that does not understand or buy into this narrative, right? And now let's be pragmatic. If what it takes to have somebody take a life-saving medicine or a vaccine, if you have to, say, well, okay, this is magic, or let's say you have to produce this with groundwater at a full moon, and then they take it, then maybe that's the right way to go. So use multiple narratives. I mean, these are extreme cases, right? But take the narrative that actually works with the worldviews, with the thinking of different parts of the population. So all of this is, of course, like hard work. We would call it marketing, but of course, there's nicer ways of labeling this, I guess. But a few don'ts and do's here. So don't only focus on one major target audience, but have from the get-go a segmented approach, a differentiated approach, where you identify those target audiences, be this target user or social, societal stakeholders that are important. Then research their interests, their needs, their wants, their barriers, their concerns, to already design your product, services, applications with new technologies in a way that they accommodate these needs. Develop differentiated narratives. So you have to talk to multiple segments, multiple groups. Do so in a dialogue among equals and not like top down. So this is the science and believe it. But give multiple narratives and talk to them in a dialogue where you can use opinion leaders, influencers, lead users, journalists, bloggers to help you with each of these communities to get your word out. And of course, analytics-wise, continuously measure your audience response and the social metrics around it. So there's a lot to do in getting the word out and getting technology accepted, especially the black box technologies that many of you are working on, right? That are difficult to understand for consumers and for users and patients and citizens, wherever you work. We will continue our research here. We would love to do research on other technologies, including nano and biotech. These would be prototypical, black box technologies for many users, patients, and consumers. We would love to work with prototypes, so that's what we're working on. Getting there instead of these verbal scenarios that we have been presenting to the respondents. We would like to experimentally test different narratives with different subsegments of the populations and the users. We are working on multilingual social media mining, so we can actually track that globally. If any of you is working like throughout the world in different languages and different places, different users. So we're working to make that work, which is less trivial than it seems in the beginning. And of course, we're always interested in real life field experiments, working with the rollout of technology. So in that respect, I hope it was interesting. Maybe some of you even have like interest in collaborating or getting more information on our research, and happy to hear from you now and then later, also at the end of the talk. I think that's where we have the discussion, right?
Thank you very much, Andreas. We have now directly the questions, and I have noted them already on my blog here. Thanks a lot for this inspiring talk, which is perfectly fitting into the area of invisible size, which is nanotechnology, definitely. And as you mentioned, nano and biotech as the potential fields where your research would be useful. I just would confirm, yes, definitely. I know that several are searching around for scientists who can upgrade their proposals with exactly this excellence and with these competencies. So, as you mentioned already in your presentation, you have specific kind of setups and tools that you use normally. Which, let's say, group of population would be the most interesting one in such research projects? Is it more the application side, so let's say the patients and the medical side, or is it more the producer side, let's say the companies that should produce something, or should it be the third group, more or less the assessment group, which should think about how to deal with the technologies? Which one would you say is the most relevant and interesting for you for the future research work?
Well, great question. I mean, I've been working personally on all these groups in different research projects, so I find all of them exciting, and each of them being like a very, very important piece of the puzzle to make things work and make technology useful to society. I would still say the largest potential I would see, especially with the new technologies we are rolling out, is with the patients, the citizens, the customers, the users side, for me personally. But others may see that differently with good reasons.
But this is exactly the point where I would say, I know from the research projects, they certainly miss out this social science in the field of, okay, technology assessment, health technology assessment, paired with the perception of those receiving the treatment, receiving whatever kind of health care and things like that. So I think that's an extremely open door on the other side, which people might not yet be thinking about a marketing institute from a university to approach. But I think you have opened with your talk exactly this area, this arena to get involved. And I think, you said it already, it would be a very interesting road to go. And if you are interested also from the other side, that you say, okay, you have some kind of research in your work where you would need this or that group to get additional participants for your studies. I think that should be also an open door. So also please add your claim. Which groups would you be keen on getting involved into your studies?
Thank you very much. Sounds great, Andreas.
Super. From that point of view, thanks once more, Andreas. We have now to go to the next speaker. It's in that case from JOANNEUM Research, Forschungsgesellschaft GmbH, the Institute Life in the unit of the Future Energy Systems and Lifestyle. It's Sara Carniello, and Sara's research includes topics like life cycle assessment, where I think some of the technologies and things which have been presented before by Andreas could also be quite interesting there. Environmental sustainability, but also sensor developments. And in her talk, she will introduce to us her view on leveraging innovation through life cycle thinking. Sara, I'm looking forward to your talk. The floor is yours.
Thank you, Andreas, for the introduction. So as Andreas introduced my talk, I will discuss, or I'd like to discuss with you what is the role and a possible level we find in life cycle thinking for innovation. It's not so common to associate sustainability with innovation and technology development, but it has actually a big potential also in this sense. I work in the Institute Life, and here we focus on sustainability and climate change and all societal and technological issues that you might relate with this. And my focus in particular is to assess the environmental impact of future technologies, or novel technologies and energy systems. Okay, few words about sustainable development. If you want to make your technology or your product sustainable, you want to contribute to some extent to sustainable development. And as you might already know, we have different dimensions in this sustainable development. So we learned already that we need to look at the economical aspects, but also to the society and to the nature. And you see here in this representation on the left that they are not necessarily at the same level. So this type of wedding cake really tells us that if you want to be economic viable, so you want to be, say, profitable on a long term, you must care also about a just society, and you will have a just society only if you take care that your impact to the nature will be as small as possible. And the basic approach that you have to follow is the life cycle thinking, which is also in the title of my presentation. Life cycle thinking means you follow your product or your project, your process or your service along all the life cycle phases. So from the raw material extraction down to the grave, so to disposal or recycling or reuse in some other way. And you don't follow only your product, but you try to put this product into the context. So you must also understand what is around your product in terms of value chain, in terms of use profiles, and also personal behavior, influence of society and socioeconomic aspects and so on. Another point is, well, to do that, you will have to map your material, energy and information flows along the value chain. So you will have to expand your perspective from the company or your unit to the full value chain, from the raw materials to the waste that you might have. And this means you will have a systemic approach to your innovation. You will embed your product or your process into the context, and you will have a multidimensional problem. And at the end of the day, it will be a complex model. So a model that is very difficult to foresee, where you might have many right answers to the same question, so many possible solutions to the same problem that you want to solve. Okay, some basics of the life cycle assessment. Life cycle assessment is the most common and the most comprehensive way to implement the life cycle thinking. It's also a very formal way to do it. It is regulated and described from ISO standards. So we have a clear framework that you want to use. And there are also, say, other ways to implement or to adopt it, but today we keep this, we focus on this. When you do this life cycle assessment, you usually do it for environmental aspects, but you could actually extend it also to the other dimensions. So you can make the same assessment also for the costs, for the economic aspects, and also for the societal aspects. And you can use it from internal perspectives, so internal purposes, support to decision making, and here we can include also innovation, but also strategic marketing, for example, operations, of course, optimization, efficiency programs, and so on. You can use it for risk assessment, because of course you have to look all around, yeah, what's happening around your product and your supply chain, so you will detect a lot of risks. And you deliver inputs for your management systems, especially, of course, environmental management systems or energy. If you will look at it from the external point of view, this assessment will deliver information you can use for compliance to regulations, and information that you can use for communication and reporting activities. And these two in particular are growing in importance for all the companies. There's almost, say, no company that can do without any reporting about the impact of the activities on the society or environment. So you see here, the life cycle assessment has, according to this framework, 4 main steps. The first one is the goal and scope. It is usually where, say, the product owners come together with the practitioners of LCA, and here we will collect the inputs, and we will define what is the objective or the objectives of our analysis. So do we want it for internal purposes or external purposes, and so on. And most importantly, what is the system we want to consider? So how far we want to go, what is relevant for us, what can we neglect, what do we need to consider, do we have different scenarios, and so on. And we will define what are the models that we need to move from the foreground data and information that the product owners know and have to the inventory. When you go to the inventory, you basically go from the input output of this system to the inputs and outputs from the technosphere to the nature, so to the biosphere. So from what you take from the nature and what you release into nature. And this means we have to map energy and material flows, and we have to understand the context and make assumptions. And this is really a key point in the study. The second important point is that when you do this assessment, we have a functional unit, or we speak about functional unit. We do not speak about product directly. We speak about the function that this product or service or process is fulfilling. And this means you can go beyond the actual product as you have it. You can compare your product also to completely different solutions that are maybe far away from your specialty, but still fulfill the same function. And if you are in an innovation team, you might also think to change your product as long as you have the function. And we might develop scenarios for different approaches, different solutions to fulfill this. So I see in these points already a big potential to use the framework that we are going to develop anyway to make the sustainability assessment, also to leverage the innovation and the creativity inside a company. And I have an example here of a project which is currently ongoing in JOANNEUM research and is embracing the 3 areas also of JOANNEUM research that are the production technologies, sustainability, and the biomedical. In this project, we have a new material, a nanomaterial that will be used in the diagnostic systems. So, say the material development and the biotech and medical aspect. And you can use this material for a lot of different things, and these partners here in the project propose different applications. So you might use this kind of tissue with nano-size pores, so that's a porosity. You can use them to release active substances in a controlled way. You can even think about a function like a pump, a capillary pump or a filter, or you can integrate some sensing layers in the lab on chip, I think is in this case, to ensure, for example, a quality control. So with this material, you can actually play on the system architecture level. You can add some functionalities that were not present before. You can definitely change, modify the production process and probably make it more cost effective or better suited for mass production. And you can improve quality control. So you might have different ways to exploit this new material in your product. So where is the sustainability in this? We will do the impact assessment here from the environmental point of view. And from the impact assessment itself, we have the two objectives. One is to compare this novel material to the current architecture and processes that are used to implement the same function into the product. And the other objective is to compare different polymers, and in this case to compare, for example, bio-based, biodegradable and fossil-based polymers. This is an example where we all tend to believe that bio-based or biodegradable are better, and for some aspects they might actually be better, but we need such a life cycle assessment to ensure we do not just shift the burden from one impact category or from one process step to the other. So we need to watch and assess the full system. And here below, you see the system at a very, very high level, very generic, that we might use for the study. So for this type of material, we would start from the substrate and then introduce the polymer that is spun on that, functional sensing materials that might be integrated, auxiliary materials of different kinds that could be additives, catalysts, glues, and so on. We will deposit, of course, and structure, if necessary, the material, and then it goes on to the assembly stage, packaging, shipping. Maybe there are some more components coming on top of this. Of course, there are a lot of testing, transport in between, and so on, to the use stage. In this case, they are all medical devices. I think they are all passive, if I'm correct here. But after the use, there will be the end of life, and here is where you can have already different scenarios. Is it for home purposes? Is it ending up in residual waste? Is it ending up in the environment, maybe in an unwanted way? Is it only for hospitals, so it is disposed in a controlled way? Can we recycle it or not? So we can already play with a lot of scenarios. So what is the lever for innovation here? If the technical team wants to change something here in the polymer, in the process, with this framework that we develop anyway for sustainability, we can see what are the consequences along the full life cycle. And we can also see what are the consequences for the supply of material, for example, or on recyclability. So we can offer a kind of model that also the technical team can use to have better, clear in mind the full system that they are going to optimize and to develop. There are a lot of challenges actually in general, but here, because of the audience we have, I put some challenges related to the nanotechnologies. the effects of nanotechnologies on the overall, say, macroscopic impact are not well modeled yet. And I want to mention here 3 challenges that we might encounter when we do this type of studies. The first one is really related to the methods. As you saw, we need to do a lot of assumptions. We need also to simplify a bit the system. And usually what do? We remove the tiny quantities. So we say if some material is less than some threshold value, 1% in weight or 0.1%, we just don't consider it. Which is, of course, a problem if you have nanotechnologies there, because they might have a significant impact on the functionality and also on the environmental effects. But of course, there will always be very tiny quantities inside the macroscopic system. So that requires a bit more clarity on the choices that we take when we do the system and the assumption. The second challenge is more technical, but it has consequences also for the sustainability and the assessment. What is the impact on recyclability of the overall system if you have some nanotechnologies embedded inside? Can we use the standard recycling processes? Do we lose maybe quality? Does it make sense to recover the nanotechnologies? They are often based on maybe critical materials or, let's say, toxic maybe materials. I'm thinking about very specific, but you might have quantum dots where you have some heavy metals inside, or there are other examples where you don't want to disperse or dilute these materials really in the environment or in other systems. So here there's a technical question: what is the impact on recyclability? And then there's also the methodological question: say, how can I reproduce this in my life cycle assessment when I do it? And the third point is related to the impact of microplastics or microfibers. That means, can we say how these materials, these nanotechnologies, will end up in the nature, in the environment, if they end up at all, of course. But you see here in this picture I took from a paper, there are different ways they can end up in the nature. There are different pathways, and we should know how they end up and what does it mean. What is the fate? So what are the consequences for the environment, for the natural systems, and also, of course, for the human being, because it's also, so the human health is also part of LCA studies in these cases. And here I must say the LCA impact categories and the models that we use are still lacking a lot of a real mapping of these effects of microplastics and microfibers on environment and on human beings. So there's a lot of research needed on this. So this is also how I want to conclude my talk, as a kind of call for actions. There is actually, I would say, a lot of potential of cooperations between nanotechnology and sustainability experts. I mentioned these 3 topics. I see here challenges for both technical and in the methodology itself. But of course, there might be also other topics. So here would be great if you have some interest in developing some ideas together, so to discuss about it. And that's all.
Thank you very much, Sara. It was really inspiring to see the cross-thinking which is included in all this life cycle thinking, and how much connectivity is needed for all that work, of course. May I ask you the one question? You mentioned the functional units, and if I think into the material science, they have mostly combined with the functional units functionalities. Is it limited to this, or goes it beyond the functionalities? Just to understand this also on the material side, how far it goes.
It is maybe a bit broader than simple functionality. It must embrace also how long it will provide this functionality, or the weight that is related to this. So the important thing is that it must really catch the functionality, as we understand as engineers, and it must be measurable, and it must be so general that I can also, with the same functional unit, I can say include also another possible solution. So it cannot be only the technical parameters that are valid only for this type of product that I have. So it must be a kind of good balance between technical functionality, but as general as possible to make also my comparison as general as possible.
Thank you. About the materials itself, you mentioned microfluidics and development of the diagnostic equipment with microfluidics and with nanotechnology inside. How far do you see, are you already in all this material science with the life cycle assessment with these types? I speak about, okay, you have raw materials, you have maybe critical raw materials, you have the substitution, and you have a kind of life cycle thinking which needs to be applied in the material science. And it also spends a little bit to the next talk then with how much of these materials are in the biomedical sector, which might be a different point of view, because some you might not be able to substitute or to change with maybe bio-based materials. How far do you see, or how much limitation do you still see at the moment with the assessment tools about the materials itself?
I see there are some really limitations in the methods. One I mentioned, so for example, the impact of microplastics is not included. Scarcity, which is also a topic. Well, I work a lot with electronics, and also there I would say scarcity of materials is important. So critical raw materials is not really clearly depicted in the methods. And on the other side, so from the technical teams, there's not so much, or the awareness is coming now, because you have these very tiny systems. You usually tend to think, well, my impact will also be very limited because it's anyway about, I don't know, micrograms or milligrams of materials, but they are usually very energy and material intensive in themselves. So you don't see them in the products, but there are there's a large use of resources to make these nanotechnologies, and the awareness is coming now. So also to say the need for this kind of studies is raising.
That is, I think, the perfect concluding remarks from your talk. The need is raising, and you are there to fulfill this need with your knowledge, with your competence. Thank you once more, Sara, for this great presentation. With this, we come to our final presentation for today. It is from Professor Aleksandr Ovsianikov. He is a founder and chief scientific officer of UpNano GmbH, a limited company based in Vienna, and he is head of the research group of 3D printing and biofabrication at the Technische University in Vienna. Topics like biomedical engineering, biotechnology, but also terms like scaffold are closely connected with Aleksandr's work. And the topic of his talk today is high resolution 3D printing, enabling innovations in my biomedical sector and beyond. So looking forward to the presentation.
Good time over there, everyone. My name is Aleksandr Ovsianikov. I'm a head of research group 3D printing and biofabrication at the TU Wien in Vienna, Austria. And I'm also a co-founder and CSO of our spin-out UpNano GmbH. Together we work on high-resolution 3D printing, and today I will tell you about how this technology enables innovations in the biomedical sector and beyond. So at the TU Wien in general, we have an interesting initiative, which is a collaborative initiative between chemistry faculty and our mechanical engineering faculty, where we work on developing this light-based technologies, so lithography-based technologies, and are able therefore to cover the whole process chain from material development to hardware and processes and applications. We've been quite successful in this regard with multiple spin-outs resulting from the group. You can see here in a picture from a press release from some time ago with multiple alumni who are now in C-level management in different companies. And cumulatively, we employ over 250 people. So today I will speak about what we do at the university and what UpNano GmbH does. And the focus is on high-resolution 3D printing, also referred to as two-photon polymerization, multi-photon lithography. So as the name hints, this technology is somewhat related to two-photon microscopy or multi-photon microscopy. And this example in this diagram here shows what this non-linear process really means. It means you're allowed to deposit the energy into the volume of material, right? So this fluorescent spot is really just localized around the focal volume of the focused laser beam. And this is the same effect that we use in order to induce photopolymerization. So we cross-link the material. In most cases, this means it transferred from liquid state to solid state, allows you to create 3D structures from polymers. You wash out the rest of the material. And in our case, we speak about true three-dimensional structuring because we're able to work in the volume without having to deposit the material layer by layer, as you have in this classical lithography technologies, which rely on linear light absorption. For the same reason, we do not need to use absorbers in our materials because we don't really rely on this linear absorption. Another aspect the specific technology provides is extremely high resolution. That's an example from a book from some years ago, showing this tiny castle on the tip of the pencil, so you can appreciate the scale. The structure is just a couple of 100 millimeters large and micrometers large, and therefore it's really challenging to create large structures with technology because it has high resolution. This is exactly the bottleneck that we've been addressing at the university here and also in the company. And with our first product, which is a tabletop 3D printing system, we in fact able to cover the whole range from having structures which are hardly visible by eye here, this Eiffel Tower and the CM image about 200 microns tall, to a structure which is 4 centimeters tall, all on the same system. This is done by using appropriate optics and appropriate also scanning algorithms and adaptive resolution that we developed. BAT mode is essentially the possibility to create large structures not limited by the working distance of the objective, similar to how you also use it in stereolithography. And bottom-up mode is where you're able to create structures within some enclosed volumes. This bottom-up mode here shows you this structure which looks like a football or like Buckminster Fullerene. And this brings me already to the first example, which is the novel tissue engineering approach enabled by this high-resolution 3D printing. In the tissue engineering approach, we use such structures, which we call microscaffolds. They are in the range of up to 300 micrometers. Therefore, they have struts of only about 35 microns. And due to this requirement for this high resolution, small feature size, there is no other technology which can produce that. And therefore, high resolution 3D printing uniquely enables this implementation of this technology by allowing us to combine such highly porous microscaffolds with cells, in this case by making cell aggregates. This is the fast process which is happening in this anti-adhesive well plates. Another aspect of this high porosity, apart from the fact that the cells can enter the structure, is that if you put multiple of these structures next to each other, the cells start to interact and fuse, creating a cohesive construct. And this is exactly the idea of this ERC consolidated grant project to create, to develop a technology which allows you rapid self-assembly of tissue construct with high cell density. I will not go into detail here, but some years ago we discussed in our opinion paper in Transit Biotechnology, indicated here at the bottom left, how this is a synergetic strategy and how it is different from the conventional approaches and why it is called third strategy in tissue engineering, by allowing us to bring forward the advantages of these different approaches while leaving the disadvantages behind. This again illustrates the process. On the left side, you can see this green fluorescent cells forming a spheroid within several hours. In the middle, non-fluorescent microscopy showing how the spheroids fuse. And the right side indicates a larger construct assembled of hundreds of these tissue units, which they, in this project, then differentiate from the stem cells into osteogenic or chondrogenic lineage in order to create bone or cartilage. So our next example is an EU project called InSight. In this EU project, what we are concerned with, and UpNano especially involved, is to create structures within microfluidic chips. So you remember this bottom-up mode. It allows you to create things within the volume, and really an interesting advantage of this technology for microfluidics is that you're able to create structures within microfluidic chip without having to disassemble and reassemble it again. And the process looks like that. You take a standard off-the-shelf microfluidic chip, inject the material into the channel, create a structure, flush the residual material out, and you're able to create such large mesh-like structures. This is just an example from UpNano, which is a gyroid structure occupying this whole channel. So it's about 16 by 4 millimeters, around 0.6 millimeters tall. The point here is that you can easily reconfigure this geometry without having to actually rebuild the chip every time. Therefore, you can create systematic experiments. And also, of course, this allows you to avoid contaminations, which would be a problem if you have to really open the chip and you cannot keep it sealed. In this EU project Insight, where apart from UpNano and TU Wien, several other projects partners are involved around the EU, which I will not mention here, but you can look it up on the website, is about creating developing a cancer immune therapy. As you might know, there is a CAR T-cell therapy, so-called T-cell therapy, where you modify patients' own cells with chimeric antigen receptors in order to bring them back into the patient and use the immune system to fight cancer. And this works quite well for some cancers. Mostly we speak about blood cancers, where it's quite efficient. This is because the cells have a good way to, this newly introduced cells, they have a good way to address and eliminate the tumor cells. But it doesn't work so well with solid tumors, right? Because of multiple factors, the physical barriers. There's still some questions about which antigens can be really used. And also another factor is how long this modified cells can persist. So the idea in the project is that it should be the right type of cells. There are different subsets, specifically stem cell memory T cells or central memory T cells, which have good anti-tumor capacity in terms of that they have a capacity for self-immune proliferation, while they also can be an efficient effector cells when it comes to antigen receptors. In order to create them, we decided that it has to be done in vitro in order to understand this whole system. In the body, the cells are generated, so to say, in the lymph node or educated in the lymph node. And the idea in this project is to create lymph node ownership in order to create these interactions of the cells, of these T cells with other cell types which are involved. In our case, the simplified version of the system will involve dendritic cells and fibroblasts in order to then educate the right type of cells in order to bring them back into the body and fight cancer. So that's the idea in this project. But in general, we see a wide applicability of where high-resolution 3D printing and specifically high-resolution bioprinting, which is the version of technology where you embed the cells into the material, allows you to reproduce some of the tissue features which are not doable with other techniques. And there you can see this in different tissues from liver with these hepatic globules, placenta barriers, which are also worked on, and so on. And this is a very nice format, especially for microfluidics and for all of these organ-on-a-chip applications. The last example I will touch upon is actually realization, not so much within the chip, but a complete microfluidic device for in vitro fertilization. This is work not done by us, but by a company with some collaboration partners in Australia. Their task was to create a microfluidic chip, allowing them to look at embryos and also create in vitro-like flow rates and shear stress in this environment. So it should be environment similar to what embryos experience in the body. So extremely slow flow rates, in this case, are achieved by creating this nice chip, which distributes the flow from this input channel into the multiple channels. Second requirement was to create these cradles where the embryo is introduced, which should be lockable, so you should be able to easily introduce them into the chip and take them out again. Of course, the design is based on CFD simulations where they have calculated how this flow distribution will look like in order to achieve this really low flow rates, which are not obtainable by conventional piezo pumps used in microfluidics. On the right side, you can in fact see a practical example. There is an embryo, and you can see in static conditions, it sits in the middle of this cradle when the flow is on, it starts moving. And here it also is media with fluorescent, with a red dye is introduced, so you can see that you can deliver things. So all of these factors allow you to, again, create much more controlled way to handle embryos. This is the mouse embryo in this case, and this guy's developing a product for human use in some years. The company is called Fertilis. The work which I showed you with was done with the University of Adelaide. The unique feature about this microfluidic chip was that it had macroscopic components, so the correct connectors which you need, and then it had to go down to those channels which are only 50 microns large. Then it had to go to the cradle connector, which had to be flexible enough to be able to snap it in, which goes down to 30 microns. And all of that was created in one go on our system in reasonable time, so about 3.5 hours for the whole chip. In part, this is enabled by using this adaptive resolution, which I mentioned in the beginning. It means, in simple terms, that you have a part of the chip where you don't actually need very high resolution. And this can be done in the coarse mode, which we do by widening your volume of light material interaction by about 10 times, allowing you to boost the throughput. And then you have areas which have to be really high resolution, like this connector points here, and also the cradle itself. And they are done in this fine mode where you really use the high resolution. Plus some specific materials which we developed in this collaboration, allowing to really flush the channels and keep them clean afterwards. So with this, I would come to conclusions. To summarize, I've demonstrated you 3 different examples. One was this novel tissue engineering approach for rapid assembly of high cell density tissue constructs, and it is enabled by high resolution 3D printing because there is no other method to produce the scaffolds. In the project Insight, we have a very interesting application of creating this lymph node on a chip, where we can really, again, control the conditions, change it, and try to study and optimize things in a really more systematic fashion. And the final example from the company and the guys in Australia is realization of this complete microfluidic chip, which is really was never done before by this high resolution technology. With this, I would like to thank you for your attention and ready to take questions. And if you have questions later on, send me an email. Thank you very much.
Thank you very much, Aleksandr, also for your flexibility due to the technical issues. You triggered one item in my head, especially on the personalized medicine topic. I mean, the tissue engineering in that case, and also the other parts you have presented, they are very much personalized, I would say. So where do you see then the broad spectrum for the application? Is it, let's say, dedicated to single patient treatments, or do you see also the chance to broaden it, let's say, with some standard parts, and then that some kind of add-ons are done to personalize at the end? I hope it's somewhat clear what I mean with that question.
Yeah, well, I think in all of the examples, this is somehow a mix of everything. So with microscaffolds, for example, the scaffold is standardized, but then of course it's the patient's own cells which come in, and that means that you know, most of the process is standard. The production itself is standard. We also have a possibility to put growth factors onto the scaffolds and put them on the shelf until they have to be used. And therefore, it is, on one hand, of course, allows you to use patient's own cells. On the other hand, it doesn't necessarily necessitate to make specialized scaffolds for that. So that's already an advantage there. Similarly, for this lymph node on a chip, the idea there is to essentially figure out the process and optimize the conditions, understand what are the performance indicators and how to affect them. And once it becomes more clear, of course, because it's much easier to construct these experiments and run them in a systematic manner in vitro, one would then, of course, use patient cells in order to adapt that and improve the outcomes. For the last example, the IVF chip, there it's this would be a completely non-really patient-specific product, so they could do things in terms of the controlling the flow rates and so on. But the idea there, I would say, is to have a standard chip, which is usable enough for many different applications, and then it can be produced in mass by in the same geometry. Yeah. So this is therefore the point where 3D printing as such, additive manufacturing, in this case specifically high resolution 3D printing, gives you the flexibility of designing things and even going to production as soon as you figured out your final product.
That sounds promising, especially it seems also that it's somehow broadened also to different fields already, and it seems like really one of those innovations that will make a big impact in the future. Thank you very much, Aleksandr, for now. I would now like to ask also the other presenters to shortly open their cameras for the final round. We have received a question about, in this case, tailored to Sara, in which it is asked, do you have any knowledge of virtuous industrial examples of successfully applied LCA?
There are a lot of examples. Yeah, it depends. I mean, if they refer to a special field of application or a special material, but a lot of LCA studies. Yeah. If this person wants to contact me, we can discuss a bit more specifically.
I think that's the perfect way forward for that, to get then directly the, let's say, references of applied LCA already. I was wondering now, if you, the three of you are here on the screen, if you think about the presentations you also have heard from the other colleagues, to my end, it has sounded like we have a really good coverage of, let's say, technology provider, assessment provider, also outreach topic, black box. I mean, the 3D printer is more or less a black box, but nicely described now by Aleksandr. How do you see, let's say, the combination of these different items coming from, okay, life cycle assessment on the one hand and ending at the product at the other hand? It would be good to have a kind of final round now from all of you. What is your, let's say, message to the colleagues out there? How, from your point of view, it's the best approach to go with the technology to the outside? Because all of you have done some kind of technology and have tailored it to certain outside. The outside is different, I know, but you tailored it to the outside. So what is your approach where you say, with this, the people will really create an impact to the outside with their work? Maybe we can start, and now in the middle of my screen, it would be Andreas. I want to put you on the brink.
Yeah, hello, thanks, Andreas. Thank you very much. These were really fantastic presentations. Thanks, Aleksandr. That's a fascinating piece of technology. Thank you, Sara. I also loved your talk, and I think the three components that we've heard, the really technical side and the LCA analysis and then the outreach side, I think these are three, maybe not the only three, but three really major factors to create an impact of technology in society. Well, as to your question, Aleksandr, for a short answer, I'm gonna say, maybe repeat myself a bit. Really work with your constituencies, with your audiences, with your stakeholders right from the start. Well, that's not new, but our stakeholders have now various platforms to communicate with each other. So figuring out what they need and where they communicate, how to communicate, has become a bit trickier, and also our technologies are becoming trickier. If I may use marketing lingo, they're becoming a more difficult sell, right? So you have to find the right narratives and approach each of these audiences with respect, and start and continue a dialogue, and also do that right from the start, so you can actually adjust your technological breakthroughs and applications to their needs. And then actually it should be easy at the end to bring them to the public and to society, to patients, customers, citizens, whatever.
Thank you very much. As you have directly addressed also Aleksandr. Maybe Aleksandr, you can now come from your side. What's your approach on that?
Yeah, so I agree here. I mean, it is a little different between academia and when you do things in the company. So in academia, of course, you look for things where which could, I mean, in our case, we focus on things which we believe could be translated and could be really put into practice somewhere. In the company, you look for feedback from the customers, you look at what is needed, and you really try to then address that. This is the best way to work.
Thank you very much. Clear and concise. Sara, you have the pleasure for having the closing remarks.
Well. Well, I will also repeat myself. I think we should, I put also myself as an engineer, we should not focus on the technical performance as itself so much. We should really be able to communicate, what is the function that this technology or this product really can fulfill, and also putting a bridge also to the marketing. I mean, at the end, it's about the value proposition that you want to sell with this technology. So what is the purpose of making it in the first place?
You know, I would love to have this discussion in the room now, and now going for a coffee with all three of you to further discuss on this topic, because that would be really amazing to then find out the aspects. And I guess we would end up with a project together, because it's so complementary what you bring, but so well connected to each other, which would be easy to step forward and to say, yeah, let's go for such a call, either in the production of the future items in the Austrian side, or maybe a bridge project or things like that. Might be ringing the one or the other bell at your end already. For now, sorry for being now 10 minutes late with our schedule. I hope you still have enjoyed the good presentations, the rich content we had here in the meeting today. I'm sure that our members, but far beyond, all our colleagues and groups all around the world, which can be watching those videos also later on, that they will be extremely interested in that. And let's continue this work in this direction for collaboration. Once more, I want to thank you all, Sara, Andreas, Aleksandr, and also Marisa. She needed to leave a little bit earlier, for your great presentations. And I also want to now close the meeting with saying also thank you to the audience, and also for the questions, and those who have still tried to directly connect. We can share afterwards the direct connection data, the email addresses of the presenters. Definitely we'll do that on our webpage, so that you can easily connect with them. If otherwise, you can always write an email to office@bnn.at, and we will directly connect you with our great presenters. With this, thank you very much for your time, for your efforts, and I wish you all great rest of the week and a super relaxing summer. Thank you very much.
Thank you.
Thank you.
Bye.
Bye-bye.
Thank you.
Bye.
Thank you.